Hey everyone, welcome back to the CHEM139 exam for 2009. This is question number 4, part A, from the short answers. So in this problem we're given four graphs, which are delta G, the free energy, versus temperature. And we're also given a bunch of data on enthalpy and entropy as well as bond dissociation energies for different species. And then we're given a number of reactions and we're asked to match the plot of delta G versus T to each reaction. So let's start with the first reaction, this one, which is 2N2O goes to N2 plus 2O2. Now in order to solve this problem we need to look at the following equation, delta G and how it varies with temperature. Well, the equation we know for that is this one, delta G equals delta H minus T delta S. Okay, and using the data that was given we can actually compute delta H and delta S for this reaction. So let's start with calculating delta H for the first reaction. Well, we know that we can calculate this using the delta H of formation of each product times its stoichiometric coefficient, so that would be sum over the products of the stoichiometric coefficient of each product times the delta H of formation of each product minus sum over the reactants of the stoichiometric coefficient of each reactant times delta H of formation of each reactant. Okay, so for this reaction, the products, we have 2 times delta H of formation of oxygen plus delta H of formation of N2 minus 2 times the delta H of formation of N2O. If you look these numbers up in the table that's given, you'll notice that the oxygen and nitrogen don't have a delta H given. That's because these are in their natural states and therefore their heat of formation is 0. And for N2O we have a delta H of formation of 82 kilojoules per mole. So that leaves us with a delta H of minus 164 kilojoules per mole. The exact same equation can be applied to the delta S calculation. So let's do the same thing. Delta S equals, now in this case the heat of formation thing being 0 in its natural state does not apply for entropy. So we're going to use all the values. So for oxygen we have 205 joules per mole Kelvin plus 191.5 joules per mole Kelvin minus 2 times 219.7 joules per mole Kelvin, which works out to 162.1 joules per mole Kelvin. So subbing these numbers into this equation, we have that delta G is equal to minus 164 kilojoules per mole minus T times 0.1621 kilojoules per mole Kelvin. So I converted the units of delta S to kilojoules from joules. Looking at this equation we can see that the slope, this is like the equation of a line. We have delta G, which is our y-axis, is equal to minus T, which is our x-axis, times 0.1621 minus 164, which is, so this is our slope, and this is our y-intercept. Okay, looking at these graphs, we can see we need to look for a graph that has a straight line with a negative y-intercept and a negative slope, which corresponds to plot B. So the answer for this one is plot B.